multiple spectra acquisition, onboard processing, and remote control. All those and even more in open source package. Hello everyone, Andrzej here. Welcome to another VIS Lab video. At the beginning I would like to answer question why I even bother. I'm on a quest of building system that can perform automatic chemical research, and to create closed loop I need some detector that can analyze composition of mixtures. And here there are certain requirements. First of all, measurements should be rather fast. Second thing, I also wish this measurement to be contactless and non-destructive. And therefore, pretty natural choice goes to spectrometry. And visible spectrum spectrometers, I think, are most accessible devices, the cheapest one and easiest to maintain. That's why I decided to go with this type of measurement. And now, second question, why I do it by myself? Basically, requirements, it needs to be fast, it needs to be customizable so I can fit it into my system, and also it needs to be affordable so I can pay it by myself. And although on the market you may find something that can measure spectrum fast, I mean in a matter of second, customizability becomes a problem. Probably you could find something like this, but affordability, well, that's the final reason why I have to do it by myself. So let's talk how this device is built. Okay, here is the source of light. Light is collected by this lens and then travels inside of this optic wire to spectrometer. But in parallel is collected through another optic wire, passing through the sample and then going again to spectrometer. Then light, when enters spectrometer, is dispersed on a grating and finally collected by this lens and projected onto the camera. Camera sends signal to Raspberry Pi 02, where it's processed and then sent to the other devices. Okay, so now we know structure of spectrometer, so let's do some measurements. And we will start with finding the concentration of copper in water solution. Here I have already prepared solutions for finding calibration curve. And when this is measured, my assistant will give me sample with unknown concentration, that is unknown to me, and I will tell you what I got. Okay, so first thing I need to adjust the parameters of this measurement, and I already found the proper shutter speed while keeping gain the lowest possible to reduce noise. And you can see this is the data collected while measuring basically nothing. So if I have this already collected, I will measure dark frame. Basically I'm clicking here, I need to wait a bit, and now I'm waiting. And I got information that the dark frame is collected. Okay, so if dark frame is collected, I remove the this piece of paper and start with measurements. First I will measure blank, which is basically pure water. And here soon you will have a result. Yeah, and then those results I just save in a memory. And now I can move to collect data for finding calibration curve. All data for calibration curve is already collected, and now friend prepared for me this solution of unknown concentration. I will measure this sample and soon I will come back with results. So I already got results and based on my calculations we should have concentration of 16.4 grams. Is it correct? How far it is from reality?
Yeah, actually it's 16.
No, so we have pretty good results. That's pretty good.
Yeah,
16.4 versus 16. Okay, so you see, we can measure concentration of solutions. So this was measurement of transmitted light. Now let's move to reflected light. Here I have a cards, pieces of paper which were marked with colorful markers, and this is something that we can measure spectrum of. To do it, I need to rearrange spectrometer. And readjust measurement conditions using this white paper as a blank. So I found correct settings for this type of experiment. I also did some blank measurement and dark frame measurement. Now I can start measuring my cards. So I put them here and measure. This is final results of reflected spectrum. Each color has diffuse and specular reflection recorded. I'm not gonna comment much about it. Just note that specular spectrum is shifted to the red in respect to diffuse. Why? Honestly, I have no idea, but if you have some, you know what to do. And that's it for today. If you are interested in more devices and upgrades to this particular spectrometer, you can expect more videos on this topic. And bye! Okay, measurements done, so we can turn off light.